All right, so this is Chapter 5, Section 2, perpendicular and angle bisectors. Here's a perpendicular bisector, and here's a little sample of an angle bisector. Our learning objective is to use properties of perpendicular and angle bisectors. All right, so all the important stuff. The first important item that I found in this section was the word equidistant. Equidistant. It means same distance, like equal distance, equidistant, same distance. It's not rocket science here. Then the distance from a point to a line is the length of the perpendicular segment from the point to a line. And I definitely want to highlight that it's perpendicular. Since our learning objective is to use properties of perpendicular bisectors, when the word perpendicular comes up, we need to put a particular note of it. All right. If we look at Theorem 5-2, it's the perpendicular bisect theorem. And the first thing I want you to do is make sure you have this picture, because this theorem makes no sense if you don't have the picture that goes with it. So I have PM cutting AB, line segment AB in half, and it's also perpendicular to PM. So if PM is perpendicular to AB, and MA, which is this bottom distance here, is equal to MB, then we can say that PA is equal to PB. So that's where these congruent line marks are. Congruent here and congruent here. The converse, we did converse a couple chapters ago, the converse of that is true. If PA is equal to PB, then we can say PM is perpendicular to AB and MA is equal to MB. So all that information is. All right, Theorem 5-4 is the angle bisector theorem. If you're wondering what happened to 5-3, it's the converse. 5-3 is the converse of perpendicular bisector theorem. So the angle bisector theorem says, and there's a whole bunch of if parts to this, so make sure you're diligent about keeping track of all these ifs. If QS bisects angle PQR, and this picture is really important, so make sure you have your picture done correctly. If QS bisects angle PQR and SP is perpendicular to QP and SR is perpendicular to QR, then we can say SP is equal to SR. The converse of that is true, but there's so many things in our if statement, I couldn't tell what ifs I needed for the converse, so I wrote down the entire converse. So if you have your perpendicular segments as drawn, and SP is equal to SR, then we can say QS bisects angle PQR. All right, so let's do these two example problems. First one we're going to look at is this picture here. So make sure you have that picture on your paper so you can follow along. What is the length of QR? QR goes from here to here. The way we're going to find this length is we're going to set it equal, because we know that we have these conditions. We know that we have perpendicular here, check. We know that we have bisector here, check. These are congruent. So we can say these sides here that come up to the vertex are congruent. So if we can say that those are equal, we can set these two items equal to each other. So we're going to subtract 3 in from both sides because we're going to solve for n and then we're going to plug it back in. Just when you thought algebra was behind you, he comes back and he's haunting. Oh, algebra. So we get n is equal to 3. That is not the answer because it says what is the length of QR. And 3 is not the length of QR. 5 times 3 minus 7 is 15 minus 7 is 8. So the answer to this is 8. All right, so our second problem is what is the length of FB, and that's this little guy here. Right now we know he's equal to 6x plus 3, and this takes the converse. That's this picture here. So it's the same picture as this property. So we know that if we have perpendicular lines and that SP is congruent to SR, then so we're here. So we know that these little legs are congruent. So we can say 6x plus 3 is equal to 4x plus 9. We subtract 4x from both sides. We subtract 3 from both sides. We divide by 2. X is equal to 3, but 3 is not the answer because the question is asking us what is the length of FB. That is 6 times 3 plus 3. That's the same as 18 plus 3, which is 21.